How are you all guys? Okay. I just want to go ahead with whatever we have done. What is that? The piecewise functions. Can we go ahead and discuss them today? So we get another piece of it. Algebra 2, right? Yeah. And I don't know whether you all noticed, I posted a SAT workbook for you all to get started. Very fundamentals. Not the real good book that you want to work on, but at least the concepts that you need to be aware of before even going for PSAT. It will really help. It covers both Algebra 1 and Geometry. Please do when you have time. When are you taking the SAT, ma? Harshika?
I'm taking it in August.
Oh wow. You're prepared nicely?
I'm like doing it right now.
Nice. Are you also going to do the ACTs?
Yeah.
Nice. After that, huh?
Yeah. If I like don't get the score that I want, then I'm gonna do the ACT, but if I get a good SAT score, then I don't know.
Oh, I see. Okay. Okay, you're doing it with writing or no?
No.
Oh, you're not taking the writing piece, is it?
No, I'm not.
I don't think it's needed. Many of them don't. I see. Okay, makes sense. Okay, now let's go ahead with wherever we left, okay? 1 second. But oh yeah, before I go there, I really want to ask you a couple of questions, right? Then only I'll know. Because in the other class, they were really finding it hard doing radians. The first piece was okay, but the second piece wasn't okay at all for them. So let's see. How about this? Do you know how to find the coterminal angles for this one? Let me ask you this. But if it's too hard, you can tell me because it's the first time we are learning, right? So I'm not expecting anything big, but at the same time, if you can, that's great. It's a win. Go ahead. What are the coterminal angles of this? I just got one answer. Mama, you find all. Sorry, guys. Find all coterminal angles. See, this one was okay when I reviewed in the last class, but when I went to radians, they found it very hard. Please, all coterminal angles, Sri Charan. Yeah. 220. Correct. Navneet, correct. Correct, ma'am. Aryan, you were there in the last class?
Uh, I think so. I think so.
Harshika, why ma 410 plus 360n?
Isn't that I just added 360 and then I
I saw that 180. What is this? This is 40, so 220. So 220 plus 360n. Okay?
does it have to be 220 or can I?
You cannot, right, ma? Because let me show you. You cannot put 410. I'll tell you why. Did I put it like this? Then yes. You see what I mean?
Yeah.
I had just asked for this one.
Okay.
So it has to be 210, right, ma?
Yeah.
I'm sorry, 2.
20.
Yeah, 220. Yeah. Okay, meaning, see, okay, with your answer, right, if I have this right, if I put n is equal to 0, does that work? No, right?
No.
Yeah, that's why.
Okay.
Okay, how about this? Okay, so you're all good with ordinary coterminal angles, is what I see. Okay, how about this? What is the measure of this angle? That's all. This is the only review I'm going to do this. What is the measure of this angle? It's a difficult one now. I don't know. 60. Wow, that's correct, Navneet. Sri Charan, that's correct. Ashrita, that's correct. Ashrita, I just asked you for the angle, ma. I just asked you for the angle, not coterminal angles. Okay, that's fine. Anya, did you get it? Aryan,
No, Auntie, I got the answer, but it's not letting me send it to you for some reason. Give me 1 second.
yeah. Aryan, I can, let me help you. This should help you. Send the answer here. You get it?
Yeah.
So that's good. Harshika, it's, how did you find out, ma?
No, I typed in the wrong thing. I know what I did wrong.
Okay, I'll move on then. If you know, I'm not going to press you on that. Okay, how about this? Okay, find the measure of each angle. You're going to find the measure of this one. I just want to go to piecewise, guys. So, meaning that way we have two topics under the belt. Small topics, but then it's all pre-calculate. So, we didn't do limits, right, guys? We didn't do limits. Okay. We can do limits as well, or piecewise functions. Okay, let's see. We'll do piecewise functions for today. We'll do piecewise functions, okay? Piecewise functions are just broken functions. Get it? Aryan, yes. This is pi by 4, no? Pi by. I really want this. 3 by 4 pi. Oh, yeah. Yeah, Harshika, that's right. Arshrita, you forgot the minus sign. Sri Charan, you forgot the minus sign as well. When you go clockwise, right, it becomes a minus sign, right? Did you guys forget?
Yeah, I forgot.
We're just finding the cotangent, right?
No, we are just finding the angle, right? Marked in red. So this is pi by 2, this is pi by 4. So that makes up
Oh,
this is 3 by 4 pi. But in a fully one turn is 2 pi. 2 pi minus 3 pi by 4 is what you're doing. So bring the denominator to a 4. So times 4 by 4. So 8 pi minus 3 pi by 4, which is 5 pi by 4. That is negative because we're going in the clockwise direction. One more. Okay, we are not yet on this one, right? Okay, in which quadrant is this? Okay, in which quadrant are these two angles? It takes time, I know, okay? Otherwise, I'll not be spending this much time too. Once you get a hang of it, you get a hang of it. Oh, wow. If you go, okay, 12. Is it correct? Sricharan, is that right?
So maybe I got like the quadrants wrong.
No, the 11th one is correct, but then, negative. Oh, sorry, Sricharan. Yeah, Sricharan, that's, no, still, yeah, that's right. That's right, Sricharan.
Wait, Auntie, I'm a little confused. Can you help me out?
Absolutely. Yeah, that's correct, Navneet. Not really, Ashrita. Somewhere something has gone wrong, Ashrita. I think one is right, one is wrong. Anya, are you following? So minus 15 by 4 pi, right? Guys, I'm going on the clockwise direction, remember, okay? How many pi's I can take it off? One full circle is always 2 pi, 2 pi, 2 pi, right? If one full circle is 2 pi, 2 pi, 2 pi, can I take away 12 pi by 4? Can I write this out as 12 pi by 4 plus 3 pi by 4? Right? On the negative side, right? 12 pi by 4 is already 12 pi by 4 is 3 pi. But I want multiples of 2 pi, right? Then what, guys? 8. Okay. So this is 8 pi. And then what? 8, 9, 10, 11, 12. Yeah, I want 2 pi, 2 pi, 2 pi. So let me keep on removing 2 pi, 2 pi, 2 pi, 2 pi. When I keep on removing 2 pi, 2 pi, 2 pi, 2 pi, what goes off? Oh, divide. Oh my gosh. Okay. This is divide by 4, right? 15 pi by 4 has how many whole pi's to it? 3 pi is there. So this is 1 pi, this is 2 pi, this is 3 pi, right? So 12 pi got over. And after that, how much I need to move? 12 pi, I accounted for 12 pi by 4, right? That is 3 pi. And after that, I have 3 pi by 4 more to go. 3 pi by 4 is somewhere here, right? Because this is 1 pi by 2 and then 1/4 pi by 4. So it lies in the first quadrant. Correct, guys? Does that make sense? Ashrita, did you get it?
Yeah, I started my circle from the first quadrant instead of the fourth.
Oh, okay. Because it's negative, right, ma? 4 by 3 pi means I'm going in the positive direction, right? So how much is this? 3 pi by pi plus pi by 3 is what is there, right? That is 4 pi by 3. 3 pi by pi is 1 pi. This is 1 pi. And after that I have to move just pi by 3. So it's in the third quadrant. Make sense?
Yeah.
This is what made the other class as well have a hard time. So early on when you start with radians, it's always trouble. But once you get used to it, it becomes easy. How about this? Measure of each angle I'm not going to ask you, okay? Which quadrant I'm going to ask you though? How about this? Which quadrant is this? Which quadrant is that? Yeah, see, one easy thing for this is go to 18 pi by 9. It's just one full circle, but then you lessen a little bit. So the angle will lie in which quadrant you have to see. See, this 17 pi by 9 is very near 18 pi by 9. Harshika, why 1 and 3, ma?
That was for the previous question.
Oh. Ashrita, why the third quadrant, Ashrita? We are going in the anti-clockwise direction, right? That you're forgetting every time. Am I wrong? I don't think so. Is it the third quadrant? We are going in the, we are going in the clockwise direction because of the negative, right?
Yeah.
So clockwise, 18 pi by 9 is 2 pi, one full circle. But then it's not one full circle, it's pi by 9 less. So it will be in which quadrant? Little tricky, right, guys? If it's in radians, it's a little tricky. What I'm saying is, because of the negative, I'll be traveling in the clockwise direction. Okay. What does this mean? 18 pi by 9 is very near. What is 18 pi by 9? One full circle. But 18 pi by 9 is a little too far. The 17 pi by 9 is pi by 9 less than that, which has to be in this quadrant. So it is the first quadrant. Make sense? Anya, I'm not getting answers from you. I don't know whether you're understanding, ma.
No, I understand.
Okay. Now, I know I'm not moving on, but guys, you need to understand as well. There's no point in going on moving. Okay. Find a coterminal angle between 0 and 2 pi. For this one, find a coterminal angle between 0 and 2 pi. Find a coterminal angle between 0 and 2 pi. Okay, let me.
In radians? Oh, yeah. Never mind.
Yeah, ma. In radians, yes. Yeah, piecewise function. Let's cover the piecewise functions today fully. Piecewise functions are just broken functions, okay? A linear, two lines, right? It's a piecewise function. You can break it into two halves. See, this line, this line. You can break this function into pieces. Piece 1, piece 2. So this becomes a piecewise function. Piecewise functions are easy to tackle. Or you can as well have this 0 and 2 pi, right? Yeah. Or you can have something like this. See, this is a piecewise function. This is one function, piece 1. This is another piece 2. So this is a piecewise function. Like that, piecewise functions are easy to deal with. We'll do that now. That seems right, Anya. Aryan, minus 11 pi by 15.
Wait, would it be the other way around? Because I thought of it like, 360, like minus, oh, then it'd be plus.
Yeah, 0 to 2 pi is here. Okay, the minuses are on this side. This is not what I want. I want an angle between this. You got it?
Yeah.
Yeah, Sricharan, that's right. Everybody got it, I think. Okay, how to do this, Aryan? For you, let me go ahead quickly. How do you do it? So basically, you have to find an angle. So you have 19 pi by 15, right? Where is this 19 pi by 15? It is 15 pi by 15, 1 pi, and then a 4 pi by 15. Right? It's so less. 4 pi by 15 is very less. Is it less than pi by 2? Yeah. Is it less than pi by 2? 1 by 2. 1 by 2 is 0.5, right? 4 by 15 is much less. Okay. So it's on the negative side. So that is a pi. This is done. And then you have 4 pi by 15. 4 pi by 15 protruding up, right? Here the thing is, how do you find coterminal angle between 0 and 2 pi? It's a negative angle first of all. So what I do, minus 19 pi by 15. As I said, right, I can keep on adding 2 pi's. Let me first add 2 pi and see. That becomes minus 19 pi plus 30 pi by 15. So that would be 11 pi by 15. This 11 pi by 15 is very much within 0 to 2 pi. So you can confidently say this is your answer.
Okay, so it's just because I put the negative, it was wrong?
Yeah, it is just going on adding or subtracting 2 pi's.
Yeah, okay, got it.
Okay, now let's go to piecewise functions. Let's see. Suppose if I give a piecewise function, as I said, right, are broken functions, broken into pieces. Suppose if I say this is my piecewise function. Suppose if I give you that this is my piecewise function. This is my piecewise function. In this case, right, there is a parabola before x is less than 1. See how I am going to visualize this is less than 1. X is less than 1. Basically, there is a parabola. Somewhere there is a downward facing parabola. Okay. And then x cube minus 5x. There is a cubic function somewhere. From 1 to 11, it's a cubic function. I don't even know how it's going to go, but somehow it's a cubic function. Okay. And then you have an inverted square root function. Inverted means it's a reflection on the x-axis. So somewhere something like this. That's what I see. Because it's split into 3 pieces. One is a parabola, cubic function, and then an inverted, the reflected square root function I have. That's all I know about this. Okay. This is a piecewise function. Whichever is cut into pieces, this is how you write a piecewise function. All the intervals you need to cover. X is less than 1 means minus infinity to 1 is this, 1 to 11 is this, and then greater than 11 is this. The worst part of a piecewise function is finding out what is that particular point which is not covered. X is less than 1 means at 1 you can use this. When they ask you what is the function's value at 1, you have to use this equation because that's what describes at 1. And then less than 11 you use this. But what is the function's value at 11? Who can tell me what is this function's value at 11? X equal to 11. What do you think? What do you think the function's value at 11 is? At 1 I know because less than 1 is this. At 1 you will use this and substitute x equal to 1 here because it says less than or equal to. But at 11 what is the value of the function? If I say g of 11, which equation will you use?
It's like an extraneous solution.
What is it?
It's like an extraneous solution.
Yeah, there's no solution, undefined. You got it? The function is undefined at x equal to 11. Makes sense? So basically it's not continuing. See, from minus infinity to 1 is this, 1 to 11 is this, but at 11 nobody has an equal to sign, neither this nor this. So at 11 it's not defined. Make sense? So my questions are, can you find out g of 1, g of 1 and g of minus 1? G of, okay, find out g of 1. I don't want g of minus 1 guys, okay? I want you to find g of 12. G of 1 and g of 12. What is the function value? So you'll have to use different equations based on the number I'm giving. Okay guys, G1 and G12. Oh, you're getting a bad value like that? Sricharan, why did you get that? 1 is a minus 2. I am so messed up. G of 1 and Sricharan, how did you get that, Sricharan?
For which one?
Yeah, that is right, Navneet. Both Sricharan.
I just
Yeah,
put
the
in
second one is
the.
right, but the first one doesn't seem right. Can you check the first one?
I just plugged in the x value into like the equation.
Into which one did you plug in?
The middle one.
The middle one, correct. So what will be your answer?
Just 3 minus 5.
3 minus 5. Why 3 minus 5? 1
Because
cube is
x.
1.
Yeah.
1 cube
And
is 1 minus 5, right?
oh my god.
No problem. Okay, I was just taken aback. Okay. Aryan, that is correct. Ashrita, that is correct. Okay, Navneet, did you? Yeah, you got it. I know. Harshika, did you get ma?
I sent my answer.
Harshika, no, please don't change it to decimals. I want it in radicals because you will plug it into the calculator. So I don't want it in decimals. So here for 12, you need to plug that in here. Okay, 36 minus 16 is minus square root of 20. You got it?
Yeah.
Yep. So that will be minus 2 root 5. Make sense? Okay, now let's go ahead with another. You're going to try this one, guys. Okay, I'm going to give another function. You're going to tell me, I'll tell you what and all I want. You can tell me one by one. Okay, h of 5 minus 10 and minus 4. Let me write down. I want h of 5, h of minus 10 and minus 4. Please, 1, 2, 3. 3 questions. I need to check this one. Yes, ma'am. Harshika, that's right. Ashrita, that's right. Aryan, third one is incorrect, Aryan. Navneet, correct. Anya, correct. One of you got it wrong, right? Let me just describe. This was incorrect, right? H of minus 4, right? Minus 4. Minus 4, I don't see it at all, right? Minus 6, till minus 6 it's there. But after that, till minus 3. Minus 6 to minus 3, the function doesn't seem to be defined at all. So this is undefined. Make sense? Need to be careful, guys, whoever answered. Okay, now let's go ahead with the next one. Okay, now this is a good exercise, okay? How are we going to graph this function? Let's see. I'm going to help you with this, okay? First one I'm going to graph. Second one you're going to graph and show me. Okay. How about this? I'm going to do this for you. Okay, it's a little hard. X is less than minus 2. So before minus 2, it's a linear equation, minus 2x minus 1. So what do I do? Can I put some values? At least 2 values if I put in only. Less than minus 2. So at minus 2, no, I cannot use that. Clearly I cannot use that. You see? So let me go ahead, put minus 3 and see. If I put minus 3, what happens? This will be a 6 minus 1, which is a 5. Right? So what did I put? X equal to minus 3 when I put y will be equal to a 5. Minus 3 comma 5. Minus 3 comma 5. That's 1 point. Okay, but I cannot put minus 2 because it has a negative slope. So it has to come down. So can I put one another? Minus 4 if I put, what happens? X equal to minus 4 if I put y will be equal to 8 minus 1, 7. Okay. So that is minus 4 comma 7. Minus 4 comma 7. So I got it. You see. Now again till minus 2 it is defined, but at minus 2 it is not defined. So basically it is coming down 2. It is coming down. See, it is coming down 2 points down, 2 units down for every 1 unit in the y-axis. So here it will be a hole. At minus 2, I cannot use that line, you see. But at minus 2, what happens? At minus 2, the first function I can't even use. Okay. So, what will I do? I will just draw this line. At minus 2, I can't use that line, but till minus 2, it is working. Okay. Now, after that, what will I do? At minus 2, it is a minus 2. Here, I have a shaded dot. Till 3, 1, 2, 3. Till 3, that line continues. Is equal to 3 is there. So, I have a shaded dot. Any questions still here? Drawing it is a little difficult initially. Did you get it, guys? Did I put a minus 3 or a minus 2? I'm sorry. Nobody is raising. Is it a minus 2 or a 2? I did a 2. It's a minus 2, right? So, it's a minus 2. Minus 2 to 3 is a minus 2. Minus 2 to 3 is a minus 2.
Hey, Miss Priya, why do we have an open circle for the previous function? Do we have to include it, or can we just like not draw it there?
You can, how do you show then? You see what I mean? How do you show? Till minus 2, it's valid. At minus 2, it's not valid. Till
So
minus 2, meaning minus 2.1, 2.01, it's valid, right?
okay, so then you keep an open circle there.
Yeah, that is why I kept an open circle. Make sense? But at minus 2, this one takes into picture. This one comes into picture. So I will have to show a shaded dot. So the vertical line test as well passes, you see?
Yeah.
Still a piecewise function. So the vertical line test passes. And here we go till 3. But more than 3, what happens? Minus x plus 5. Minus x plus 5 means, okay, greater than 3, right? Greater than 3 means at, let's say at 4. At 4, what happens? X equal to 4, y equal to 1. X equal to 5, y equal to 0. What does that mean? 4 comma 1, 5 comma 0. 4 comma 1, 5 comma 0. Oh, is it like that? Okay, great. 4 comma 1, 5 comma 0. It's a negative sloped line. How to draw that line? 4 comma 1, 5 comma 0 MC. So if that is the case, I need to have a 4 comma 1, 5 comma 0, but it is coming till greater than 3, not at 3. So how will I draw that line? Let me see. Not at 3, greater than 3, right? Makes sense, guys? Makes sense? This is how I draw the piecewise function. Drawing the piecewise function is a little hard to start with. Okay, the problematic ones are these. You have to decide based on your equal to sign. So that is the hardest part. Okay. One another thing, the way I make sure it's right is it's a negative slope. So it has to come down. This is also a negative slope line. So it has to go down. This is a constant line. That's how I recheck. Okay, can you draw one for me? Let's see. It's basically breaking the function into three things, right? So let's see. How about this? This is a hard one. I don't want to give you this. Everything becomes so hard. Okay, how about this? This is okay. Draw this one. I want to draw one more function by myself and show you. That's the hard one. Try this one. This one is easy. Yes, Aryan, go ahead, Aryan. Just keep your video on, that's all. Just go. Yeah, please do it and show it on the video. I would like to see your graphs. Just one you do, one more I will do. 1 minute, Amma. Ashita, 1 minute, Amma. I have a question. Okay, the first line, right, is it ending in a whole ma, Ashrita? The rest of it is correct.
Yes, there's an open circle right there.
Okay, and you remember you can mark the vertex of the parabola, right? You have not marked the vertex of the parabola. That's easy to mark because it's in vertex form. 1, 4, those are the subtle things they'll check. 1, -4 is the vertex of the parabola. So mark 2 points in the parabola, that helps, and usually it's given in vertex form. Vertex is easy. So
Okay.
those are the things that carry forward from your algebra 1.
Okay.
And this one is a positive slope line, so it has to go up, the first one.
Yeah, it is going up.
Yeah, I saw rest of it is correct. Only thing is you did not, vertex, because your parabola just like that didn't go down and go up. You see, because of the vertex missing. That's all.
Okay.
Yeah, and it is not defined between -1 and 0.
Yes.
Yeah, I will show you one more.
Okay.
I'll show you one more that's a little difficult. I will show you that. Oh, that's right. Great. No, Sri Charan. The first line seems incorrect to me. The parabola is correct, but that line seems incorrect. There's something wrong. Did you... Sri Charan, show me. Because see, it is less than -1, right, ma? Not really, Anya. Anya, that's a... Oh, Anya. Okay. For Anya, for some reason, it's just tilted to me. Okay, I think it's right, Anya, yours. Sri Charan, is that right? Can you show me once more, Sri Charan?
Don't do that.
No. Oh, yeah, is it right? But that doesn't feel right to me, Sri Charan. I'll tell you why. Can I put it out on the board? Or should I wait?
I think I get why.
Huh?
Miss
think I know
Priya,
why.
can you check my
Yeah,
graph?
yeah, I can, yeah. Are you sending it to me or showing? Anything? Amma, you have to unblur your background, ma. I cannot see, right, ma? Yeah. Yeah, that seems right, Harshika. That seems right. Navneet, are you getting it? This should be. Sricharan, this is why I said. Did you see?
Yeah, I just realized.
Yeah, no problem.
Yeah, I got that.
Okay, you got that. Okay. So, okay, let me show you one more. That's a little. That is called the greatest integer function. I want you to have a heads up on that. Okay, I'll give you one more harder one to draw. Okay. Okay, guys. How about this? Write out the function for me. Write out the function. Write out the piecewise function. You're going to write the equation. This is the function in the graph. Write out the piecewise function. I'll do one harder problem for sure on the board. But before that, write out the function equation. Minus infinity to minus 1. You can define it using a constant function. And then minus 1 to 4. Not to 4, to infinity, right? The equal to sign, you need to be very careful at minus 1. So, once you understand the very basic of piecewise function, it's very easy. Okay, I'll just finish up the concepts and then do harder problems. Because that way you can say, oh, okay, I learned piecewise functions. Harshika, less than or equal to, I don't know.
Miss Priya, you're muted.
Sorry, thank you, Navneet. Aryan is not yet back. Okay, so this is the function. Okay, can I move on? It's an easy one. Okay, I gave you an easy one so that you feel comfortable about it. Okay, so how about this? they will make it harder. Okay, let's first do the harder one that I said, and then we'll see. I'll do two hard ones. Okay, so let's see this one. This one is not a fully greatest integer function, but then I'm going to do this. Okay, so let's see. This is purely a pain to draw this. Okay, -5 to -3. 1 2 3 4 5 -5 -3. Let me do this. It's a -4. See, the thing is, it goes till -3. -5 to -3, it goes to -4. Okay, this is a -4, and then -3 to 0, -3 to 0, it's a -1. See, here I have to draw a hole, and then to -1. It is on -1 till 0. 0 is a dotted. See, these are very important. If you change all this, it will be a mess in pre-calc. Okay, then 0 to 1, it's a hole, but it is a 2. It goes till 1, and it's a 2. See, and then 2 to 4, there is a hole, but it goes to a 5. See, this is the greatest integer function. It goes to a 4, right? From 2. What did I do, guys? There is a mistake. Oh my gosh. Okay. 2 to a 4. 2 is a 5. That's a hole. You see? Then till 4. You need to be just careful. That's all. Makes sense, guys? So basically this represents a greatest integer function, not fully, but we will cover the greatest integer function later. Okay, this is called a step function. This is more of a step function. We have never come across that in algebra 2. Okay, this is like a step, right? But it has different holes and different shaded points at different places. Okay, step functions is another subtopic. Like piecewise functions, step function is another subtopic. Step functions are like this. But step function, it is a function, so it has to pass the vertical line test, but it will look like it is steps when you draw the graph. But this does not get you a full step function. There is some problem with it, but this is the function. Can I move on? Okay, I'm going to draw one more that's hard. Okay, let's see. How about this? This I feel is hard, honestly. Let's see. I will draw it. Okay, this one, let's try, guys. 1 2 3 -3 -2 -1. So what happens here? Less than -3 is 3x plus 10. Oh wow, 3x plus 10, and there is a hole. Okay, so when I substitute -4, it's a -2. When I substitute -5, it's a -5. So -4 -2, -4 -2, -4 -2. It's a point on the line. -5 -5. You see, but that comes till -3. Okay, -2 -5, and then again it has to come 3 points. It comes till -3. Okay, so if I substitute -3.1, let's see. If I substitute -3.1 here, it will come -9.3 plus 10. So it is a -0.7. It is a plus. Okay, so it comes till here. This is my line. Does that make sense, the first one? If there is a problem, you have to let me know. Does that make sense? And after that, what happened to the second one? See, -3 has a dot here on the second one. That is an x square plus 5. Minus x square plus 5 is a downward facing parabola. However, -3 is covered. If I put in -3, what happens? It's a -1. If I put in -3 here, it will become a +6. But -6 plus 1 is a -1. So -3 has -1. So that's a dot. And after that, it goes till what? Till 1 it goes. Oh my gosh. till 1 it goes, but 1 is not getting covered. So let me put a 0 as a 5. 0 is a 5. You see? Vertex, I don't have it, but you can do minus b by 2a. Minus b by 2a is the x coordinate of the vertex. Minus b by 2a is what? Minus b, 0 is the vertex. Oh, 0 point is the vertex. Huh? Oh, wow. 0 point seems to be the vertex. Yeah. 0 point seems to be the vertex of the parabola. You see? 0 point seems to be the vertex of the parabola. So it goes from here to there. You see? Till 1 it goes. I don't know. Till 1 only it goes, but that's again a hole. Okay. And then at x equal to 1, there is a 2. At x equal to 1, there is a 2. And then x greater than 1. What is this function? This is an absolute value function. It's pushed up by 3 and moved to the right by 3. Oh my goodness. So let's see, greater than 1. So if I put x equal to 2, what happens? 2 minus 1, minus 1. 1 minus 3 is a minus 2. So basically, what is the vertex of that? What is the vertex of this? 3 comma minus 3 is the vertex. 3 comma minus 3 is the vertex of that function. 3 comma minus 3 is the vertex of the absolute value function. Are you all with me?
Yes.
Yeah, it becomes slightly difficult, definitely. But then greater than 1. So 1.1 as well, this is valid. If I put a, sorry guys, 1 second. Suppose if I put a 1.1 there, right? If I put a 1.1 here, what happens?
I finished 6.01, 6.03 quizzes. I need to take the 11th
I'll come. Let me finish. 1.1 minus 3 is what? So 1.1 minus 3 is like 2.9, right? So 2.9 minus 3 is a minus 0.1, right? Minus 0.1. So here it is a minus 0.1 somewhere here. Okay, so but that is a whole, see, it comes till there, but at exactly 1 it's a hole. Okay, so somewhere here it goes till here. This is my vertex, minus 3 comma 3, and then it goes up. You see, does it make sense, guys? So it's still a function. It passes the vertical line test even here because it's only 1 point. Any questions? But you can expect things like this. Okay, the ones that we did are very easy. Okay, I'll post one homework on this, but you know what? I really want to cover one single pointer. Okay, how do you say that a piecewise function is continuous or not? How do you say that a piecewise function is continuous or not? Okay, let me give you two functions. You can tell if it is a continuous function or not. Okay, how about this? Is this a continuous function? Means it should be defined everywhere. Okay, but a piecewise function is not continuous if it skips domains. Is it a continuous function or not? Quick comma, this should be easy. With this we'll conclude. Let's see. Is it continuous or not? Is it continuous or not? Is it continuous or not? Meaning, see, choose the points where you're doubtful. Meaning, let's see. I'll show you. Okay, I'll show you. I have two functions for you to tell me whether it is continuous or not. So basically, the first one. See, clearly x equal to 5 is not defined at all. Is it continuous? No. X equal to 5, there is no definition of the function. So it is not continuous. Okay. How about this? Here, this seems to be continuous because minus 1, greater than minus 1, less than minus 1, equal to minus 1. Everything is defined. But can I try? What happens? Can I try what happens to see? Let's see what happens. Okay. So let me put less than minus 1. At less than minus 1, what is the value? Less than minus 1 means if it is less than minus 1, I'll put a minus 1 and C here. What happens? It is a 2. And then when it is equal to minus 1, it is at a 3. Oh my God, 2 to 3, there is no connection. You see, less than minus 1, it's at a value of 2. But then at minus 1, it is 3. Then greater than minus 1, what happens? If you put minus 1 in here, what happens? Minus 1 the whole square. So 1 square plus 1 is 2. You see, yeah, this is good. 2, 2. The y values are 2, 2. But then at x equal to minus 1, suddenly it goes to a 3. There is a skip somewhere. You see, there is no continuity. So this function is not continuous. Does that make sense? You have to evaluate at that particular point and see. Similarly for 5, less than 5 is okay. You can evaluate this and see. Greater than 5, evaluate this and see. If they both are equal, fine. But equal to 5 is not even defined. So it's not continuous. Make sense?
Yes.
Okay. I'll stop here. Any questions, stay. Otherwise, we'll start the summer classes in the second week of June. That is June 8th will be the first day of class. Not for this group. Maybe that weekend for you. Any questions? We'll just work on AP Pre-Calc. Any questions? Let me know. If you don't have any questions, have a nice summer. Have a relaxed break. Okay? But let me know what you're all doing. That's it.
Is this the last class of the session?
Yes. 22.
Okay.
22 is our last class for the entire, across all the groups. So this will be the last class for this class. So I just wanted you to know at least 2-3 topics before we barge into AP Pre-Calc. Okay. Any questions for me?
No.
Okay.
No.
See you all soon. Have a nice break.
Thank you.
Okay, thank you, Miss Priya. Bye.
Bye, guys.